Alrighty, welcome to today's presentation. Today we're going to be going over an introduction to Linux. And here are the topics for today. Alrighty, so first of all, what is Linux? So Linux is a family of Unix-like operating systems based on the Linux kernel, which was created and led by Linus Torvalds. And by the way, this is the same man who also created Git. So, there are many different distributions, or what we call flavors, of Linux. And some examples are Ubuntu, Debian, Kali, Fedora, and Arch. Those are just a few examples. Linux is also an open source operating system. It's lightweight, and it is highly customizable. And then also it is usually offered with or without GUI. And that kind of depends on if you're running the server version of the operating system or the desktop version. And then finally, Linux can run on most hardware. It's actually one of the most widely supported operating systems. So, why use Linux? So in our club, SC Robotics, we're using the Linux distribution Ubuntu. And the reason why we're specifically using this distribution is because it's widely supported for robotics applications. So that means there are a lot of different libraries that are built for Linux. The OS is very stable. It's very easy to learn how to use Ubuntu because it offers a desktop interface, but it also has the capability for a non-interface server to use with robotics as well. All right, and here's a continuation of that. So on the left, you can see Ubuntu desktop. And this is actually a screenshot of my desktop. You can see the Intro to Linux presentation. And then on the right is an example of what you would see when you're logging into Ubuntu server. So you're not actually getting a GUI interface, you're only getting the terminal interface. And so for the Ubuntu desktop, it's a nice interface, it's customizable, and it's also very similar to other GUI operating systems like Windows and Mac OS. So it's very nice to, if you want to start off with Linux, it's very nice to begin with a distribution of Linux that has a desktop operating system so that you can choose when you really want to use the terminal and when you do not want to. And then on the right, there's Ubuntu Server. The reason to choose this is that it's very lightweight, has minimal overhead, so that means it doesn't use a lot of memory, doesn't use a lot of storage, doesn't use a lot of CPU computation, and also no monitor is required for the computer that it runs on. And then we'll see in a couple slides or so how you're actually going to connect to Ubuntu server or even Ubuntu desktop remotely. Here it is. So what is Secure Shell or SSH? So the Secure Shell protocol is a cryptographic network protocol for operating network services securely over an unsecured network. So what that pretty much means is when you go to remotely connect to a computer, the traffic between your computer and the remote computer is going to be encrypted so that people cannot spy on that information. And it uses end-to-end encryption. So, for example, to connect to Ubuntu server, the command would be SSH user at hostname. And this is actually how to connect to any computer. But pretty much you can see in the bottom right an example of someone SSHing into a computer. And if I actually just exit right now, I'm going to show you an SSH into my Raspberry Pi that I have beside me right now. It is actually connected over Wi-Fi to the same network that my laptop is currently connected to. So if I just go SSH and then the username that's on the Pi, Cameron, at, and then the host name, which can be either an IP address or if you have a domain name for it. So right now I have rpi.local as the name, or the name is RPI, and you say .local because it is on the local network. There we go. Let's put in the password. And then we are in. So this is how I access my Raspberry Pi. And now I can type in Linux commands to make changes on the operating system. And if I just hit Control D, closes the connection and logs me out. And then also just wanted to mention that SSH actually works on it, or it should work on most operating systems. So it works on Windows, works on Linux, and it works on Mac OS. So for SSH, some software actually lets you SSH and use GUI features to interact with a remote system. So for example, Visual Studio Code actually has an extension that lets you edit code files on a remote system. So if I were to go and open up VS Code right now, I could actually click the remote extension right here, choose my rpi.local down here, and then click connect. I would have to put a password prompt would come up. I'd put in my password, and then on the left here you can see all the code files. And it makes editing code files much easier than doing it right in the terminal. So let's talk about package managers. So what is a package manager? A package manager is a tool that allows you to install, remove, upgrade, or configure and manage software packages on an operating system. And I say on an operating system because package managers exist for Windows, Mac OS, and Linux, and any type of operating system. So some common package managers that you'll be using on Linux, there's apt, snap, and pip. And pip is a Python package manager. So most package managers will have similar commands such as install, remove, or uninstall, and list and upgrade. And so you can see in the images from left to right, you can see I type in apt and it shows some command options for apt. Type in pip3 for pip Python 3, Python version 3 pip. And you see the same types of commands, and also you see snap, which is also a package manager, which has similar commands as well. And so package managers pull packages from something called a repository. So what is a repository? A repository is a group of packages. And you can just imagine it being also kind of like a Git repository where it's a folder structure that contains different packages that you can download from. So But in this case, when you actually go, actually, hold on one second. A package manager, first of all, a package. So yeah, a repository is a group of packages, and a package is a piece of software. And repositories can be added and removed from a package manager. And packages can be downloaded and installed from repositories. So pretty much on your system, so this is what I was going towards. So pretty much on your system, you'll actually add the repository to the package manager, and now that package manager has information about what packages are available to be downloaded. So it doesn't actually download all packages to your computer. It just gives you information on what packages are available. And then from that, you're able to use like the install command, for example, to actually reference the repository and the package from that repository and install it on your system. So let's talk about APT, Advanced Package Tool. So some common commands for APT would be apt update, which downloads package lists from repositories and updates information about the packages in question. So that means like the versions, the new up-to-date versions, so that let's say you have an older version of a piece of software. Now the repository knows that the package is out of date and will ask you if you want to update it. We also have apt upgrade, which updates outdated packages to their latest versions. You have apt install, which is used to install a package. Apt remove, which is used to remove a package. And apt list, which lists packages available, installed, and packages that are upgradable. And so these are just some common commands from apt. So now let's talk about some Linux commands. So first of all, we have the command sudo. This is going to be an important command that you will be using a lot while on your journey through Linux. So sudo pretty much allows you to temporarily elevate your current user account to have root privileges. So just like Windows, when you run an application as administrator, this is pretty much the same thing that it does, but on Linux. So then we have cd, which is change directory. So when you're going through the file system in the terminal, you can change the directory to another part of the file system. We also have ls, which lists files and directories, so that you can see what files are available and what directories you can change to. We have tree, which shows a directory tree. We have clear, which clears the terminal. So you'll have a blank terminal ready to have commands entered. And then we have make dir, which creates a new directory or a new folder. We have touch, which is used to create files. We have rm, which is used to remove a file. We have rm, and then the arguments or the options -r and f. And this is used to remove a folder and its contents recursively. If you don't use the -rf and try to remove a folder that contains contents, it will not work. Then we have mv, which is used to move a file or folder, and it also can be used to rename a file or folder. And then we have cp, which is for copying a file or folder, and make sure you use cp-r when you want to copy a folder that contains contents. It will look recursively into the contents of the folder and copy those as well. And then we have cat, which reads out data from a file. So if you say cat and then file.txt, for example, it will read out that data. And then you have history, which shows history of the commands you typed in. So this is nice in case you have a really long command that you typed in and want to find it. So also something to mention, when you press the tab key, this actually allows for auto completion. And it will show you available directories as well. And then pressing the up and down arrows will let you move through previous commands. All right, so we have a few other commands to talk about. So we have Python 3, which is specifically for Python, the language. And pretty much this is used to run a Python script. You'd say Python 3 and then your Python script. We also have chmod, which is used to set file and folder permissions. So pretty much files and folders, just like in Windows and other operating systems, have read, write, and executable permissions. If a file does not have an executable permission, for example, then the operating system will not be allowed to execute the code that's contained within the file. If it doesn't have a read permission, then the operating system cannot read the file. And if it does not have a write permission, then it cannot write to a file. And pretty much what you would do to, for example, let's say you create a bash script, which a bash script is a script that contains bash commands, which pretty much Linux commands. And you can actually run the file and it will run through whatever Linux commands you put into the bash file. And so right from the get-go, the bash file may not contain executable permissions. So when you try to run it, it won't allow you to. So you would have to do chmod plus x and then your bash file name, and that would get it permissions, and then you could execute the file. So to actually execute a file, you're going to either want to use source or dot. So both of these things are exactly the same. Writing out source and then a file name, it runs an executable. Also dot and then a space and a file name also runs an executable. And then also a good mention is if you need quick information about a command, and let's say, and this is also very good if let's say you don't currently have internet, you can actually use the --help flag after writing a command, and it will usually give information about the command and how to use it. So, and then if you want more in-depth information, sometimes software will come with, and commands will come with manuals. And so you can use the man command to open up a manual. So for example, if I type in man ls, it'll give me information about the list command. All right, and now let's talk about text editing tools for the commands line. So in Linux, you won't always have access to a desktop. For example, when you're using Ubuntu server. So you would usually use if you want to make quick changes, you'd usually use a text editor within the terminal. So a few common ones, or a couple common ones, we have Nano, which is a simple text editor. You can imagine it like Notepad for Windows. And so when you type Nano, opens the editor. You can type in a file. You can type and then save a file somewhere containing the content, or you can open a file that's already existing. and open it for editing. And then there's also Vim, which is an advanced text editor, and this is more like this has more features, and it's kind of like a code editor. So it has lots of features, lots of useful shortcuts, and you can create files from it using it, and also edit existing files. And so actually, if I go here, go ahead and open up Nano, you can see new buffer. So that just means it created some space in memory, so I can type stuff, and I can go ahead, save modified buffer, and say yes, and then I would name a file whatever .txt, and then I would be able to access that later. But I'm going to exit without saving the buffer. And we have Vim, so VI. And then if I do escape I, you start typing stuff. And then if I want to quit and write to a file, you do escape : quit and write. So QW. If you want to just quit, it's Q exclamation. And that won't save anything. And there are many, many other shortcuts. All right, so what are some ways that you can start with Linux? So, for example, something you can do is installing it as a single operating system. So you can do this either on a computer that you only want Linux on, or for example, you can also install it on a Raspberry Pi and access it from there. You can also have the choice of a dual boot, which I'm currently doing on my laptop, where I have Windows installed, but I also have Linux installed, and I can restart the computer and boot into whatever operating system of my choosing. And then also, you can have a virtual machine, which is a piece of software that emulates a bare metal system and can run different operating systems. So pretty much you would run this piece of software on your current operating system, but you'd be able to use Linux as well. So a few different types of virtual systems. One that's really good for Windows is called Windows Subsystem for Linux, and the most up-to-date version is actually WSL2. And then we also have UTM, which is for macOS. We have VirtualBox, and we also have Parallels, which I'm pretty sure is also for macOS. And there are many others. And then finally, another option is cloud access. So services such as AWS and Microsoft Azure will give you the ability to access Linux from the cloud. And so let's go ahead and practice some commands. So actually, if you have a macOS system, most of these commands should work fine on them. And if you have Linux, then that's even better. So let's go ahead and open the terminal. And let's see. So let's clear. And what are we going to do here? All right, let's go and so CD, if you just type CD, it's just going to go to your home directory. We're already in our home directory, so it's going to stay. So let's do ls. So you can see my home directory. And then we're going to go to documents, so CD, documents, and if I hit tab, it doesn't autocomplete it yet because documents and downloads have the same DO, but if I hit tab again, it will show the ones that it would like to autocomplete. So now I can just say C, tab, and then it autocompletes. So we're here, Now let's go ahead and ls, make sure I don't already have it. And then let me go ahead and make dir. So we're making a new directory or new folder called practice. Then we're gonna go ahead and let's see. So let's do an ls right there. You can see the practice folder. And then let's go ahead and actually go into the directory practice. I think I forgot to add that to the slides. But ls, so nothing's in practice right now. Then let's create a text file called temp.txt. So touch temp.txt, do ls, we can see the files there. Now we want to edit the file. So nano temp. It should work without sudo right now, because I didn't create it with sudo. So we're in temp.txt, you can see at the top. And then I'm just going to type hello world, Control X, Y, and then save by pressing enter. There we go. And then if we do cat temp.txt, it says hello world inside. So let me actually clear this. See what else is here. Then, so yeah, temp is still in here. Let's go ahead and remove temp.txt. We don't need the rf because it's not a folder that contains contents, so it will delete. Then we do ls. You can see it's not there anymore. Now we can do cd dot dot, which goes back a directory. And you can actually see if you do ls-a, which shows all directories and including hidden directories, you can see that currently in my directory that I previously, if I do ls, says nothing, you can actually see a dot dot and a dot, and these are reference points to the previous directory, and the dots is the current directory. So if I just do cd dot, nothing's going to happen because it's saying change directory to current directory, but we're already in current directory. But sometimes you may need to reference the current directory, so that's why the dot exists. So let's go back to directory, dot dot. Now we're in documents. Let's do ls. We're back here. We see practice. Let's go back to practice. Boom. cd practice. ls. Nothing's there. Alrighty. If I clears my terminal. So I'm just going to go ahead and go back one. Boom. Remove the practice. And you'll see cannot remove because it's directory, so this command doesn't work for that. Because this directory is actually empty, you can actually also use rmdir. There we go. But otherwise, you would have to use rm-f because it's a folder. But you can include the r there as well. But there's just nothing in it to recursively track. So that should be it for that. All right. So, and that's about it. Thank you.